Correct? So, hello guys, welcome to iitiansgateclasses. So, am I audible? You guys can write in chat. Those who are watching this session can respond in chat. Please quickly respond in chat and share this session with your friends. Okay, all right. So, let's start. So, in today's session, we are discussing GATE 2009 Aerospace Engineering paper and mechanical vibration part. After 2009, we will be discussing 2010 paper as well as and 2011 also for mechanical vibration part. So in GATE 2009, there are total 5 questions for 9 marks. Okay, so there are 4 2 marks question and one is 1 mark question. And this GATE 2009 paper, when I appeared in GATE Aerospace Engineering paper in my final year, and this is my paper, okay, and that time I got AR 41, okay, and my marks were around 57 marks. So it's like old memories, okay. So read the question. First question is question number 18. What it says: for a critically damped single degree of freedom spring mass damper system with a damping constant C of 4 Newton second per meter and spring constant K of 16 Newton per meter, the system mass is. So it's a critically damped, right? So we know, guys, in case of uh, critically damped system, your damping coefficient C becomes Cc, right? And we know what is Cc. We know what is Cc. Cc is always, it is 2 under root Km. Now, guys, in this case, they have given C. C is how much? 4 Newton second per meter, and they have given K value. What is unknown? Mass. So, what it will be if you find, if you do calculation? So, C is how much? 4 equal to 2 under root 16 m. So, what we get? We get 2 equal to 4 under root m. Okay. Then we get zero point 0.5 equal to under root m, and then m will become how much? 0.25 kg when you take square. Clear, guys, this question? So what is the answer? What is the answer, Assis? So this system is critically damped. In case of critically damped system, your damping coefficient C will be equal to Cc, which is what? Critically damped coefficient, and we know already that in terms of stiffness and mass. So B is the answer. B is the answer. Let's move to next question. What it says? Yeah. So this question is from 2 degree of freedom system. We have solved a similar question in last session also. What it says: for the spring mass system shown below, the natural frequencies are. Now, guys, tell me, this system is what? 2 degrees of freedom 1 degree or other? I just told 2 degrees of freedom, right? But you guys also tell how we have 2 degrees of freedom. Why not? It is a 1 degree of freedom. Okay, why it is 2 degrees of freedom? Because there are two masses and both masses will require independent displacement to define the motion. Now guys, in case of 2 degrees of freedom, we have the standard configuration. What is the standard configuration? We know when you have a spring mass system connected like this, so this is K1, this is mass M1, then spring K2, and then mass M2, and then again a spring K3. For this configuration, what is your frequency equation? What is the frequency equation, guys? We know my frequency equation is given by what? M1 M2 m1 m2 omega power 4 minus m1 multiplied by what? K2 plus K3. Then m2 is multiplied by what? K1 plus K2 omega square, then plus K1 K2 plus K2 K3 plus K3 K1 equal to 0. If you remember just this equation, you can solve this question. Now in this given problem, what is the K1, guys? What is K2 and what is K3? Anybody can tell what is K1, K2 and K3? Quickly guys, respond. Sai Lakshmi, what is K1 in this problem? What is K1? Is there any spring here? No. So your K1 is 0. Is there any spring here? No. So what is K3? 0. What is the K2? It is equal to K. And masses are given already M1 and M2. So it is what? 0 K 0. Good side. So now substitute 0 K and 0 in this equation. So what we see? We'll get M1 M2 m1 m2 omega power 4 minus. Now guys, what we get? K1 is 0, K3 is 0, but K2 is non-zero. So what we get? Minus m1 plus m2 into K omega square and then plus 0. All these three terms will be 0 because K1 and K3 is 0. So equal to 0. Now guys, easily we can solve this equation because one we get omega square equal to 0 and another omega square will be what? It will equal to m1 plus m2 into k by m1 m2. So what will be the natural frequency? It will be 0 comma under root m1 plus m2 upon m1 m2 into k. Clear guys? So what is the answer? So what is the answer guys? A is the correct answer. A is correct answer. So clear? Now, next question. So, next question is very good question. Okay, and this is one of the best question among one or two other question asked from free vibration. Okay, so this question, in fact, there is a mistake in IGC key already available on website. So you guys correct also. I'll explain this question correctly. Okay, so and similar questions also we have given in mock exams, and I think recently someone shared also that question in group, so you guys can understand that question if you understand this. So read the question what it says. A uniform rigid bar of mass m equal to 1 kg and length l equal to 1 meter is pivoted at A. It is supported by a spring of stiffness K equal to 1 Newton per meter and a viscous damper of damping constant C equal to 1 Newton second per meter with A equal to 1 upon under root 3 meter as shown below. The moment of inertia of the rigid bar is IA. So they directly gave for this rigid bar what is the mass moment of inertia about point A. If it is not given, then we have to find using parallelogram theorem. Okay, so that kind of questions also asked in GATE ME, and we have solved such questions during our classes. Now guys, in this case, if you see, if I just rotate this problem by 90 degrees, so what it will become? It will become a rigid bar hanging, and then it is connected by a spring, okay, of stiffness K, and it is at what distance? A distance, and then there is a damper, okay, and the damping coefficient is given as C. Okay, now guys, when this rigid bar vibrate, okay, about this pivot point A, how it will be vibrating? How it will be vibrating? If you see guys, it will be vibrating like this. Okay, now if you see this motion, if you see this motion, so suppose it is moving in this direction, so at any moment the angle is theta, right? The angle is theta if you consider this position, so angle is theta, right? Now if angle is theta and it is moving from equilibrium in anti-clockwise direction, so where will be mass moment of inertia? Anybody? It will be in opposite direction, and what it will be? It will be ia theta double dot. Is it clear? Yes or no? Now when it is moving in anti-clockwise direction from this equilibrium position, this spring will compress. When this spring get compressed, there will be a spring force in opposite direction. So what it will be? It will be K into, what is this displacement? It will be A into theta. So what will be spring force? It will be K into A theta. Now this spring force K into A theta about this pivot point will create a moment, and that moment will be in the same direction of inertia. So what is that moment? It will be Ka theta into A distance. Okay. So this is what Ka theta into A. Now guys, talk about this damper. Now guys, we know the damper will oppose the motion, right? So what will be the force in this viscous damper? It will be Cx dot. We all know, right? What is the force due to damping? It is Cx dot in case of viscous damper. Okay, in this there will be translational motion. Now guys, this x dot will be what will be x dot? Can anybody tell what will be x dot in this case, where you have a you have what we say rotational vibration? It's not translational vibration. What is X naught? Anybody? What will be X naught? Quickly, if anybody knows. So X naught in this case will be nothing but L theta naught. L theta naught. Because at any position, what is your relation between X and theta? It is X into that distance into theta, right? And we already know the total length is L. So at this location, what is your displacement? It is A into it is L into theta. So your X naught will be L theta dot. Now we got what is the force due to damper? It is C into L theta dot, and it is in opposite direction of motion. Now this force will also create a moment which will be in the same direction of inertia, right? So what it will be? It will be CL theta dot, CL theta dot into L. About which point? Pivot point A. Now guys, if you write the equation of motion about point A, what it will be? It will be IA theta double dot plus CL square theta dot plus K A square theta is equal to 0. Now we all know, in case of damped free vibration, rotational vibration, what is equation of motion? It is usually I theta double dot plus CT theta dot plus KT theta equal to 0. Till now, is it clear, everyone, how we have derived the equation of motion using Newton's method? Sahil, Ashish, is this question clear? As a Sahil, I already told, there is some typo in that solution which is available, okay, already. Is it clear? Guys, do respond quickly. Okay, that's good to hear. That's good to hear. Okay, fine. So now, guys, if you see here, we already know in case of rotational vibration, we know already in case of rotational vibration, what is natural frequency omega n? So omega n is always kt by I, okay, or J. That is what? Mass moment of inertia, right? So in this case, it is Ia. Now, what is the KT? We are getting Ka square. Now, what is your Ia given? In given problem, what is the Ia value? Ia is given as what? ML square by 3. It is what? ML square by 3. Okay. Now, guys, in given problem, what is A? A is given as what? 1 by under root 3 or L by under root 3. It is given as how much? L by under root 3. You guys can see it is 1 by under root 3, and L we know is how much? 1 meter. L we already know it is what? 1 meter. So substitute that in this problem. What we see? We see K, it is L square by 3 upon ml square by 3. So what we find? Omega n under root k by m. Okay. Now what is K and M? What is the K? K is 1 Newton per meter, and what is M? It is 1. Okay. So what we see? 1 by 1. So what is natural frequency? 1 radian per second. 1 radian per second. Now guys, with this much solution, can you answer? Can you answer with this much solution? Okay. Even in fact, in this case, it's not required to find natural frequency. Before that, what we need to do? What we need to do, Sai, Ashish? What we need to find before finding natural frequency? We have found it's fine. But in this case, in fact, it is not required. What? Is this sufficient to tell answer with this information? If, then what is the answer? Okay, I think this is not sufficient. So first we need to define this given system is what, overdamped or underdamped or critically damped. Now one thing is sure, we found natural frequency as 1 radian per second. That means D cannot be the answer. D cannot be the answer. So now guys, in case of rotational vibration, what is the zeta? What is the zeta? Zeta will be CTC by C. Sorry, zeta will be what? CT, or you can say C rotational upon CR rotational critical. Okay. In case of rotational vibration, it is not simply C by CC. It is what? Because the equation is same for torsional and rotational vibration, so I have already written it is what, ct by ctc. Okay. Now guys, what is the ct? What is the ct? In our problem, what is the ct? Ct is nothing but cl square. So just write down, it is what, cl square. Now what is this guys? CTC. What is CTC? It will be 2I omega n. It is what? 2I omega n. It is 2I omega n. What is I guys? What is I? Mr. Sahil here. What is the I? I is what? Your mass moment of inertia. Okay. Or in this case, it is what, vibration is about pivot point A, so it is 2I omega. Now guys, in this problem, C is given. How much is the C value? How much is C value? C is 1 Newton second per meter. What is the L? It is also 1, so it is what, 1 into 1 square. Now 2. What is the I value? I is given as what, ml cube by 3, right? It is how much? I is given ml square by 3, not ml cube. It is ml square by 3. So m is how much? 1. M is how much? 1. L is how much? 1 square by 3. Now what is the omega 1? Omega n we got 1. So now guys, tell me, when you solve this, what is the zeta value is coming? What is the zeta value is coming? Sahil, what is the zeta value is coming? 1.5. So tell me, the system is what? Underdamped or overdamped or critically damped? It is overdamped. So the previous omega n, where it was useful, this was also indeed required to find where it was used. It was used here, right? We have to substitute here to in the uh, critical damping coefficient part, right? So what is the answer? What is the correct answer for this question? It's not critically damped, it's not under damped. So what it is? It is over damped. So what is the answer? What it is? So Sahil, are you understanding how to approach problems? Clear? So A is the correct answer. In this case, A is the correct answer. Okay, good guys. So let's move to next question. What it says? Yeah. So read this question. So this question is from mechanical vibration of continuous system. So what it says? The partial differential equation for the torsional vibration of shaft of length L, torsional rigidity Gj, and mass polar moment of inertia per unit length I is I dou square theta by dou t square plus equal to gj dou square theta by dou x square. So this is what governing differential equation, where theta is what? Angle of twist. So in question number 56, what it is asked, if the shaft is fixed at both the ends, the boundary conditions are. So we know guys, in case of vibration of shaft, what are the boundary condition we use? We use the boundary condition at fixed end. At fixed end, what is the boundary condition, Mr. Sail? At fixed end, what is the boundary condition? This part is already done, right? In fact, this question is also solved during 2 degree and continuous system. So Sail, tell me, at fixed end, what is the boundary condition for vibration of shaft, or vibration of bar or rod, or vibration of string? What boundary condition we use at fixed end? Hmm? Anybody else? What boundary condition we use, guys? Okay. So we know at fixed end, the boundary condition is what? Your displacement. Okay. Your displacement or rotation is 0. And what is the boundary condition at free end? We use the rate of change of displacement or slope is 0. So dou theta by dou x is 0. We use that free end. Now in this case, the shaft is fixed at both the ends. So what will be your boundary condition? Your boundary condition will be what? Theta at x equal to 0 is 0, and theta at x equal to L is 0. So what is the answer? B is the answer. Clear? Everybody, is it clear? Okay. Now, guys, when your bar or rod or shaft or string, when fixed on both the ends, then your natural frequency or your mode shape will be governed by what? The mode shape will be governed by sinusoid, right? It will be sinusoidal, not causal. So they have already given, you guys can see, the mode is governed by sinusoidal, right? So we already know this sine n pi x by l is what it is. Sine, basically what it is, it is sine omega by cx. Am I correct? Yes or no, guys? It is sine omega by cx. Yes or no? In last class also similar question was there from B. Now guys, here if you compare, then what we find, what is your omega by c is coming here? Omega by c will be pi by L. Now what is the c? C is velocity of wave propagation. So here we will find natural frequency omega. So here they given sine n pi by lx, right? So that means here we need to multiply n. So what omega n we get? We get n pi by L into c. Now c in this case, what is the governing equation they have given? This. So we all know, right? Usually what is the governing equation? It is dou square theta by dou x square equal to 1 upon c square dou square theta by dou t square. So this is what the governing differential equation, guys. So now guys, if you compare in this case, if you compare, just a moment guys, all is fine, right? Yeah, it's correct only. So when you compare, guys, this equation with given governing differential equation, so what is your c square? What is your c square? C square will be gj by I. So what will be c? It will be under root gj by I. So what is c? C is velocity of wave propagation, and your natural frequency omega n is given by n pi by L under root gj by I. So guys, tell me what is the correct answer for question number 56? What is the correct answer? What is the correct answer, guys? So I will just explain further. A is the correct answer. But basically, when you write generalized solution, how the generalized solution theta x comma t is given? If you guys remember, it is what? A sine omega by cx plus b cos of omega by cx into what? C sine omega t plus d cos of omega t. Am I correct? This is what the generalized solution. Okay, so guys, here A and B are the constant which we find from what? Boundary condition, and C and D are the constant which we find from initial condition. So in this case, they have given, right, both the ends are fixed. When both the ends are fixed, we already know your B will be 0, and since A cannot be 0, so your sine omega by c x will be 0, and we know when sine is 0, if sine is n, when sine is 0, sine n pi, right? When sine is 0, sine n pi. Okay. Okay. So that's how from here you can see Sam. Omega by C will be coming as how much? N pi by L. Now guys, why this X I have substituted L? Because I am using the boundary condition. What boundary condition? Theta at L equal to 0 boundary condition. Okay. Theta at X equal to L, 0 boundary condition. Okay. Fine. So I think these many question only in GATE 2009. Now we'll move to next GATE 2010 paper. And in GATE 2010 paper, there is only one question. Okay. In GATE 2010 paper, there is only one question from mechanical vibration and it is for 2 marks. So let's see that question, what it says. Read. During an underdamped oscillation of a single degree of freedom system in the time displacement plot, the third peak is of magnitude 100 and 10th peak is of magnitude 10. They ask what? The damping ratio zeta. So guys, in this question, you need to be clear about what, how many cycles are happened. Okay, so they given us what? X tenth amplitude is given as what? X third, not tenth. X tenth is given as 10 and X third they given it as how much? 100. So usually the number of cycle how we find? We find it as n and n will be what? It will be the last amplitude. So it is how much? 10th. And what is your first amplitude? They mention third amplitude. So what it is? 3. So how many total number of cycle? It is 7. And we know the logarithmic decay delta is given by what? It is 1 by n ln of 1 by n ln of x first upon or x, we better we write x ith upon x initial upon x final. So x initial how much is? It is here in this case they given as third and final is how much? 7. So what it will be delta? Delta will be 1 upon 7 ln of x third upon x seventh. So it is nothing but what? 1 by 7 ln of x third is 100 and x seventh is how much? Sorry, not seventh, x tenth actually. It is tenth. Okay, it is tenth. They given tenth. Okay, not seventh. X tenth. So it x tenth is how much? X tenth is how much? 10. So guys, from here find out first delta, and once you know delta, we know already delta is approximately equal to what? 2 pi zeta, and zeta is here unknown. So what will be zeta? So zeta will be 1 upon 14 pi ln of 10. So Sahil, can you find this value? How much we get? Ln of 10 by 14 pi. Yeah, very good. So it is coming as how much? It is coming as 0.052. So what is the answer? What is the answer? A is the correct answer for this. So clear everyone how to solve this logarithmic decay based problem, and they have asked multiple times guys. What mistake people do? They usually do mistake in finding this n value. This n. So n value is always what? That last amplitude minus initial amplitude. Sometimes they tell the last amplitude is nth amplitude and initial amplitude is what? Zeroth amplitude. If they say initial amplitude is what? Zero. So the number of cycle will be what? It will be n. Okay, n minus 0. But in this case, what will be your delta? So delta will be given by what? If I write here in this scenario, what will be delta? So your delta will be given by what? 1 by n ln of x naught by x n. Clear guys? Is this point clear? Hopefully it should be clear, and it is very important concept to understand the how to find the number of cycle which are already happened. Okay, so let's move to next paper, gate 2011. Okay, so in gate 2011, if you see how many questions from mechanical vibration. So there is only there are two question guys. There are two question from mechanical vibration. And both questions are for 1 mark. So let's see the first question guys, what it says. So tell me the answer guys. This is a straightforward question. So what is the answer? Question number 9. A is the answer. Okay, so we will see how A is the answer. Quickly we can see that. Okay, we'll just see. Just a moment, guys. Okay, so I think my slide is here not visible. Okay, so let me write, guys, what we see here. In all, what they asked, consider a single degree of freedom. Consider a single degree of freedom spring mass damper system with mass and Yeah. So what it is given? Consider a single degree of freedom spring mass system. Okay. Mass damper system with mass damping and stiffness of mck respectively. The logarithmic decrement of the system can be calculated using. So we know, guys, the logarithmic decay delta is given by what? 2 pi zeta, sorry, 2 pi 2 pi zeta upon under root 1 minus zeta square. And we already know, guys, what zeta? Zeta is given by C by Cc, and Cc is what? 2 under root Km. Now, guys, if you substitute the zeta value in this equation, you will end up with what? You will get 2 pi C upon 2 under root k m divided by what? You'll get under root 1 minus c square by 4 km. Now, guys, now further you simplify, what we get from here. If you further simplify, we will get 2 pi c upon 2 under root km upon, we get under root 4 km minus c square upon 2 under root km. So this got cancelled. So what finally we get? We get finally option A. So option A is correct. Okay, option A is correct. Now let's move to next question. What it says? It was a very simple question. Yeah. So what it says, consider a single degree of freedom spring mass system of spring stiffness K1 and mass M, which has a natural frequency of 10 radian per second. Consider another single degree of freedom spring mass system of spring stiffness K2 and mass M, which has natural frequency 20 radian per second. The spring stiffness K2 is equal to. So, guys, in this case, they are keeping mass same. They are keeping mass same, but what they are changing? Stiffness they are changing. Initially, they have natural frequency omega 1, which is what? 10, and in this case, it is what? Under root k1 by m. Now, in case second, their natural frequency is 20, but your stiffness is what? Under root k2, so it is what? Under root k2 by m. So mass is same. Now, guys, just divide 1 by 2. So what we get? If you divide 1 by 2, we get 1 by 2 equal to under root k1 by k2. So what is asked in problem? K2 in terms of k1. So, guys, from here, what we see? What is your k2? If you square it, your from here your k2 will be equal to 4 times k1, right? So what is the answer? Quickly, guys, what is the answer? So D is the answer. Now, Sahil, I want to ask you one thing. When we solve some 10 question, today I think we have solved 7 8 question, right? Out of that, right, how many are tough? Maybe one or two, right? Or two, three question, right? Clear, na? So at least we can solve 5 question, right? Why we should worry about those 2 3 question? My point is clear, Swastik. So you should study every subject in such a way that at least those easy 4 5 question we should not lose. We should not over worry about those 2 3 tough question, right? Clear? Because in 65 question, I have already told you how many questions you have to do. It's around 50%, right? To get desired result, right? So let's not worry, do your best. Okay, all you will get best result. Igicians will rock, there is no doubt. Okay, Igicians will rock, there is no doubt about that. So that's all from today's session. We will meet in next session today for aerodynamics, and then we have another session for flight mechanics as well. And I think I have done from my part. So guys, uh, we are starting our next batch from Feb 18th and Feb 18th. So you guys be free to inform to your friends, juniors, and anybody who is looking for ride support. You guys can contact us on our contact number, or people can write to mail to us, or they can visit our website and can get all the details. You guys also subscribe us on YouTube for more updates, as well as you guys can join our Telegram group where we share daily quiz, aero engineering related jobs, and anything else whichever comes to us related to aerospace engineering. So that's all from my side today. And if you guys have any question, you guys can ask. Okay. Otherwise, we will wind up this session. Thank you all.